Hi guys, so today I'm making you a video about the unit circle. You may or may not have heard of this before. It is very useful in trigonometry to evaluate certain sines, cosines, tangents, and all the other functions, okay? Using a circle with a radius of 1, right? So to refresh your memory, a radius, right, is from the center to any point on the circle. So radius of 1 in every direction, okay? I'm going to be, so I'll probably post a picture of this online, but I have this right here on I made a little printout so I can write on it and show you. Okay, it's kind of, a lot to explain, so I'm going to do my best to explain it remotely. All right, so I'm going to have this posted also, which just shows. Okay, so if I have this circle, this is a radius of 1. So that means this is 1, this is 1. Any of these lines from the center to the point here, these are all radii, right? So you can ultimately make a triangle with any of these, right? You can make a right triangle in this circle, okay? And if this is my angle right here, as I showed you the other day on the homework, from if an angle starting here and rotating upward here, this would be a 30-degree angle, right? If I rotated here to this angle right here, that would be, you could have a 45-degree angle, right? If I went up to here, I can have another triangle right here, another triangle that gives you that would be 60-degree angle, okay? And so on and so forth. So this would be a 90-degree angle and a 120-degree angle and so on. And they are also measured in radians, okay? So 30 degrees is the equivalent of pi over 6 radians. Remember when I told you pi is like 180 degrees? So 180 over 6 gives you 30 degrees. So this is pi over 6. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. Pi over 2 is 90 degrees, okay? And so on and so forth. The videos, when they're really long, it's kind of hard to upload them. It takes forever, so I'm trying not to make this too long. But the way that you get these over here is, for example, if this one right here is 1 pi over 6, right? This hunk. This other hunk would be 2 pi over 6, which is the same thing as pi over 3, right? If I wrote 2 pi over 6, right, that would cancel out and you'd get pi over 3. So that's 1 pi over 6, 2 pi over 6, 3 pi over 6, which is the same as pi over 2, 4 pi over 6, which is the same as 2 pi over 3. 5 pi over 6 can't be reduced, so it stays like that. 6 pi over 6, the 6's cancel and you'd get pi. All right, so it continues around the circle like that. So what's important is this here. Your sine, your sine is your y's and your cosine is your x of the coordinates. So why is that? The sine of theta is y over r. You know how the sine is opposite over hypotenuse? Right, that's SOHCAHTOA, opposite over hypotenuse. If we look at this triangle here, my opposite side is whatever this leg is, which isn't that my y, right? My y distance. My hypotenuse is my radius, right? My hypotenuse is my radius, which in this unit circle is always 1, right? So if my radius is 1, I'd have y over 1, which is just y. So that's why your sine is your y coordinate, and same reason for your x, your cosine. Cosine is adjacent over hypotenuse. So if I'm using this triangle here, my adjacent side is this side, this x distance. And my hypotenuse, again, is my radius of 1. So you'd have equals x over 1, which equals x. So that's why your cosine is your x coordinate. So anytime you look at these coordinates, this is your cosine, right? Your cosine is your x, and your sine is your y. So if I were to say, what is the cosine of 30 degrees? since cosine is your x, I would just go up here to 30 degrees, and I would say the cosine of 30 degrees is radical 3 over 2. So imagine how useful that could be if you kind of have this in your head. What is the sine of 30 degrees? Well, I'm going to go up here to 30 degrees, and I know that the y is 1/2, which is the sine. So the sine of 30 degrees is 1/2. Okay? Now, how would I do that with tangent? Okay, tangent is your y over your x, which is also the same as your sine over your cosine, right? Because your sine is your y and your cosine is your x. So y over x. Why is that? Because if I'm on this triangle, what is sine? Isn't sine opposite over adjacent? So my opposite side is my y, my adjacent side is my x, so that's why sine is tangent is y over x. So the tangent is opposite over adjacent, so that's why you have tangent as y over x. Okay, so if I were to ask you what is the tangent here, I'm going to have to do a little bit work. So if I ask you what is the tangent of 30 degrees, I'm going to have to go over here to 30 degrees. I'm going to see these coordinates. I'm going to say, well, tangent is y over x. So if I want to find, let me try to write it here without getting in the way. If I want to find the tangent of 30 degrees, my paper is moving, hold on. If I want to find the tangent of 30 degrees, right, well, my y is 1/2 over my x, which is radical 3 over 2, right? So I know that's going to be, I'm going to continue down here. That's 1/2 multiplied by the reciprocal. Those will cancel, and I'll get 1 over radical 3, which I have to simplify to radical 3 over 3. Are we okay with those simplifying? Remember, I cannot have a radical in my denominator, so I will multiply by radical 3 over radical 3, and that's how I get radical 3 over 3. Okay, I put a video about that the other day if you want to check. So the tangent of 30 degrees is radical 3 over 3. So that's how you can use your unit circle to help you. Okay, same thing. What would the tangent be of 45 degrees? Well, I'm going to go up here to 45 degrees, right, which is this big triangle right here, right? And what are my coordinates? If I want the tangent of this, tangent is y over x, so radical 2 over 2 over itself is going to be 1. So the tangent of 45 degrees, because you have this triangle with two of the same legs, is going to be, the tangent is 1, okay? Your cosine of 45 degrees is radical 2 over 2. Your sine is also radical 2 over 2. Okay, so if somebody said, what is the sine of 2 pi over 3? Right? If I said, what is the sine of 2 pi over 3? Right? I would go on my unit circle to right here where I have 2 pi over 3. It's the same thing as 120 degrees, but let's just say we're in radians. What is the sine of 2 pi over 3? Well, my sine is my y, right? So what are my y coordinates at 2 pi over 3? Radical 3 over 2. So the sine of 2 pi over 3 is radical 3 over 2. All right, so do you get how the unit circle works? Same thing goes if I want to find the other one, secant, cosecant, cotangent. I would have to, so for example, if I said, what is my cosecant of 2 pi over 3? Well, so cosecant is the reciprocal of sine, right? So if I want the reciprocal of sine, I would just flip it, and then my cosecant is going to be 2 over radical 3, right? Which I would simplify to 2 radical 3. I just got a little blurry. 2 radical 3 over 3, and that would be the simplified version. Okay, what else? There's something else I wanted to tell you. Oh, yeah, quadrants. Quadrants are important. So you'll see at the top here, again, I'm going to post a picture of this. It's going to be really helpful to you. I have an A, an S, a T, and a C in each quadrant. Quadrant 1, quadrant 2. Is that blurry? Try not to make it blurry. It looks a little blurry. That's better. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So the way that they made a little math thing to remember, all students take calculus. That's where the A, S, T, C comes in. All students take calculus. So this just means when is it positive? When is it positive or negative? So in this quadrant, okay, everything is positive. There's nothing negative. All the things are positive and there's nothing negative. Why is that? Because you're in quadrant 1. My x's are positive and my y's are positive. So no matter what you do, if you do y over x or x over y, everything's going to be positive, right? In quadrant 2, the S stands for sign. That means only sign is positive. Okay? Only sign is positive. Everything else is negative. And also, it's reciprocal. So if sign is positive, cosecant is positive. Okay? So why is that? Because when I'm in this quadrant, aren't my x's negative? Right? And my y's are positive? So that's why only your sign is positive and it's reciprocal. And then the t here is tangent is positive only, and everything else is negative. Why is that? Because when you're in quadrant 3, your x's are negative, right? And your y's are negative. So if I have my tangent of y over x and I have a negative over a negative, that makes it positive, right? So that's why that goes. And then in the 4th quadrant, only cosine is positive. Why? Because my x's are positive over here and my y's are negative over here in this quadrant. All right, so all students take calculus. This is going to come in handy moving forward, because if I say, hi, I have a 30-degree angle in quadrant 2, you're going to figure out, I'll show you later how to figure that out, but you're going to have to know what is it going to be positive or negative, and that's how it's going to, that's how that's going to help you. Okay, so I'm at about 12 minutes now. I think I'm going to stop that right now, and I'm going to post a picture of this unit circle stuff, and I'm also going to post an assignment. So the assignment's going to be things like, what is the tangent of pi over 3, right? And then you'll have to go over here to use your unit circle. I'm going to have you use the unit circle to answer this, and then you're going to have to do, all right, my tangent is y over x, so I'm going to do that, right? Or what is this secant of pi over 2? I'm going to go over here, right? Secant is the reciprocal of cosine. And if cosine is 0, your secant is going to be 1 over 0, which means it's undefined, right? So I'll talk more about the undefined stuff later. Okay, so let's just take it. There's a lot for me to explain, so we can just take it from there. All right, have a great day. Bye.